8.4, Part 1. We'll be going over logarithms, specifically the definition of a logarithm with base b, and then examples 1 and 2. So the definition of a logarithm with base b, so it says let b and y be positive numbers and b is not equal to 1. So we're not talking about base 1 at all. The logarithm of y with base b is denoted by log base b of y and is defined as follows. Log base b of y is equal to x if and only if b to the x power is equal to y. So b to the x power is equal to y means that the log base b of y is equal to x. So in other words, logarithm is the inverse of an exponential function. So the expression is read log base b of y. Okay, so example 1, rewriting a logarithmic equation. So we're going to rewrite it in exponential form. So we've got a, b, c, d, and e here. So I'll go ahead and rotate my colors. So log base 3 of 81 is equal to 4. Okay, so in other words, 3 to the 4th power is equal to 81. And I can actually show that 3 times 3 is 9, times 3 is 27, times 3 again is equal to 81. Okay. Log base 4 of 1 is equal to 0. So in other words, 4 to the 0 power is equal to 1. Well, anything to the 0 power is equal to 1. Okay. Log base 9 of 9 is equal to 1. So in other words, 9 to the 1st power is equal to 9. Well, anything to the 1st power is just equal to itself. Log base 10 of 0.01 is equal to negative 2. So 10 to the negative 2 power is equal to 0.01. Or in other words, 10 to the negative 2 power is equal to 1 over 10 squared, which is equal to 1 over 100, which is 0.01, 1/100th. Okay. And then finally, log base 1/4 of 4 is equal to negative 1, or 1/4 to the negative 1 power is equal to 4. Okay, and remember the negative power of something is a reciprocal just like in the one above, so x to the negative 1 power is 1 over x. So the reciprocal of 1/4 is 4. Okay, now we've got special logarithmic values. So the logarithm of 1. So log base b of 1 is equal to 0 because the only way that we can get 1 as the result of a power is if we take something to the 0 power. Anything to the 0 power is equal to 1. And then the logarithm of base b, so in other words, if I take the same base of the base of that logarithm, we're equal to 1 because only b to the 1st power is going to be equal to b. Okay. All right, and so now example 2, we're going to evaluate each of the expressions. So to help you find the value log base b of y, ask yourself what power of b gives you y. So for a, it says 2 to what power gives 64? Well, 2 times 2 is 4 times 2 again is 8, times 2 again is 16, times 2 again is 32, times 2 again is 64. So that's 2 to the 6th power. So 2 multiplied by itself 6 times. So 2 to the 6th power is equal to 64. So log base 2 of 64 is equal to 6. That's the exponent that I would put on 2 to get to 64. Okay, 1/2 to what power gives 0.25? Well, 0.25 is 1/4, so 1/2 times 1/2 is equal to 1/4. So 1/2 squared equals 0.25. So log base 1/2 of 0.25 is 2, because 1/2 raised to the 2nd power gives us 1/4. 1/3 to what power gives 27? Well, I know 3 to the 3rd power gives me 27, and I have 1/3, so I need to make it a reciprocal, so that would be -3. So the negative takes the reciprocal, so it becomes 3 to the 3rd power. So 1/3 to the -3rd power is the same as 3 to the 3rd power. So if 1/3 to the -3 power is equal to 27, that means that log base 1/3 of 27 is equal to -3. So 1/3 to the -3 power gives us 27. Okay. And then finally, 4 to what power gives 2? Well, 2 is the square root of 4, and the other way that we can write square root is to the 1/2 power. So remember, in rational exponents, if we take a half power, that's the same as taking the square root. So if 4 to the 1/2 power is equal to 2, that means that log base 4 of 2 is equal to 1/2, because 4 to the 1/2 power is equal to the square root of 4 is equal to 2.